Hello students, welcome to the world of chemistry. This is Dr. Vikram Panchal and I'm dealing with thermodynamics. In this lecture series, this is lecture number 15. In this lecture, I'll discuss about work. Is it a state function or not? For that, we'll take one example of argon gas, pressure P1, volume V1. It is converted into argon gas, pressure P2, volume V2. Now the condition is V1 is greater than V2. That means initial volume of argon is greater than final volume of argon, and therefore P2 will be greater than P1 or P1 is less than P2. That means pressure increases. So this is an example of compression of gas. During compression of argon gas, we will see that how the work is a state function or not. So first of all, let us discuss the first route for this process. So we'll take first route, and that is with the graph only we can understand this. This is the pressure versus volume graph, and here we consider this as V2 and this is V1 because V1 is greater than V2, that's why, and this must be P1 and this is P2 and P2 is greater than P1, that is why P2 will be here. And suppose this is P1, V1 will be the initial state. So here we are at initial state. And now we have to reach the final state, which is this one. This is the final state. Now, if you want to reach from initial state to final state, there are two routes, and first of all, we'll discuss the first route. The route number 1, in which the first part will be, we will move from V1 to V2. That means we decrease volume and keeping pressure constant. So this is the route. First of all, we will come here and we reach here. Okay, at V2. Here pressure P1 remain constant. Okay, so this is the first route, first part of the route from initial state P1 V1 to now we will reach to P1 V2. Okay, and here pressure is constant, only volume decreases. Okay, and here as volume decreases, this is isobaric process. Why? Because pressure is constant, and as volume decreases at constant pressure, this must be cooling process. So this is cooling process and also isobaric process. Okay, Now, second part of this, it can be here, where we will move from P1 to P2. Okay, and here we can say that we increase pressure. We increase the pressure keeping volume constant, and if you keep volume constant, there will be effect on temperature. Okay, so here volume is constant and we are increasing pressure. Okay, therefore we can say that pressure increases and it must be due to heating. That means when pressure increases, heating takes place. It is also known as isochoric process. Why? Because we are not changing volume. So it is isochoric process. Isochoric process. And here we will move from P1 to P2 like this. This is called heating. Now, in this case, the work done during this process is only where the volume changes. Okay, only where the volume changes. So let us see this one. For root 1, W1 is work done. And W1 is equal to integration minus sign outside V1 to V2 P1 dV minus V2 to V2 P dV. Okay, these are the two processes. But in second one, as volume remain constant, that means dV will be 0. Therefore, V2 to V2 P dV will be 0. Okay, and therefore here this part will be 0. So we can write W1 is equal to minus P1 bracket V2 minus V1, or W1 is equal to, if you convert this into V2 minus V1, then it may negative become positive. So P1 V1 minus V2, you can write any one of these. But since V1 is greater than V2, then V1 minus V2 will be greater than 0 or positive, and therefore W1 will be greater than 0. That means when compression takes place, work will be done on the system. So here we can say that it is work done on the system. Okay, W1 is work done on the system. Why? Because compression of gas takes place. That is compression of gas. And now in this case, let us consider what is the work done. So this part is work done, where only volume changes. So this is work done, or we call it W1. Okay, so this is W1, where this much work is done during the first root. Now let us take the second root. route number 2, where again with the graph, it is a graph of pressure versus volume. This is V2 and here we have V1. This is P1 and P2. V1 is greater than V2 and P2 is greater than P1. That's why we write like this. This is your initial state. So this is your initial state. And here we have final state. We have to reach over here. So this is the final state. Okay. Now we have to remove this. We should reach to final state from initial state. Then second route, where first of all the first part of the second route is this one. We go from P1 to P2. There volume is constant and therefore it is called isochoric process. It is also called heating. So first of all we reach here from P1 to P2 without changing volume, and this is nothing but heating. And here work done is not possible. Why? Because there is no change in volume. Second route, where we move from V1 to V2 keeping pressure constant, and that is called isobaric process, or this is called cooling. So we reach here and it is cooling. Okay, so first of all heating and then cooling. This is cooling. And we reach to the final state. So this is second route. Now for this route, let us write W, work done. What is work done? In this case, work done is W2, and W2 is equal to integration negative sign V1 to V1 P dV minus V1 to V2 P2 dV. In first case, you see the volume does not changes, and therefore if V1 minus V1 will be 0. Therefore dV will be 0 for first case, V1 minus V1, and therefore V1 to V1 P dV will be 0. Okay, so W2 will be minus, sorry, here I made a mistake. This should be V1. So V1 to V2 and here P2 dV. P2 dV. Okay, and this is equal to minus P2 V2 minus V1, or W2 is equal to minus P2 V1 minus V2. Again V1 minus V2, sorry, plus P2. And as V1 is greater than V2, therefore V1 minus V2 will be greater than 0. Therefore W2 is also greater than 0. Okay, so W2 is greater than 0. Now let us see, because it is compression, that is why. So let us see what is W2 in this case. So the W2 would be this much. This is work done and it is called W2.